Let's see some basic concepts of digital image processing. Before moving on to the concept, first let's know what is digital image processing. Digital image is represented as the two-dimensional function, that is f of x comma y. X comma y represent the coordinates of the image. At location x comma y, f represent the gray value at that particular location, which means f of x comma y means x comma y represent the coordinate value, f represent the gray level at that particular location. So the combination of all the pixels is referred as the digital image. Next, if the x, y and f are finite and discrete quantities, then that is referred as the digital image. Digital image processing means processing the digital image by using some digital computer, that is referred as digital image processing. Next, let's see some fundamental steps in the digital image processing. There are totally 10 steps are there. The first one is image acquisition and the second one is image enhancement, next image restoration and next color image processing. After that, wavelet and multi-resolution processing, next compression, after that morphological processing, next segmentation, representation and finally object recognition. These are the 10 fundamental steps done in the digital image processing. And the center one is referred as the knowledge base, that is referred as the problem domain we are given into that of digital image processing. For all the steps, the input is digital image, but for the last four steps, the output is referred as the attributes, and remaining 6, the output is digital image. Let's see in detail about each and every steps. The first step is image acquisition, that is capturing the image by using some physical device, which may be of camera or some the digital image. The first step is capturing the image by using the physical device. There may be some pre-processing such as scaling also done. And the second one is image enhancement. After the image is captured, we can done some enhancements by using some arithmetical ALU, arithmetic and logical units. And the next one is image restoration. While capturing the image as well as transferring it into that of other systems, there may be some noise may be added. That noise are rectified from the image and we are restoring back the image to the original. That is referred as the image restoration. While considering image enhancement, that is referred as the subjective one. That may be based upon the human preferences, that is optional. But image restoration is referred as the objective. That is, we have to done the image restoration, then only we can get the very clear image. And the next step is color image processing. While we are using the colors in the image, there are a lot of color models are there. HSI color model, RGB color model and CMY color models are there. Depending upon the color models we have used, we can process the image. So that is referred as the color image processing. And the next one is wavelet. Wavelet represents the resolution of the particular image. Resolution means the number of pixels used to represent the image. So we can increase the resolution to provide a better quality. And the next one is compression. Compression in the sense that focusing upon the storage space used for the image. We have to reduce the storage of the image for the better improvements. There are a lot of formats are there, JPEG, GIF. Depending upon the formats, we have to reduce the storage of the image. And the next one is morphological processing, that deals with the tools used to extract some features from the image. And the next one is segmentation. Segmentation means partition the images into objects as well as into the constituent parts. If there is an image in the sense, we have to extract some of the objects, that is referred as the segmentation. And the next one is representation and description. Representation means after the object is extracted from the image, we have to denote it by means of two representation. The first one is boundary representation and the second one is regional representation. Boundary representation that represent the boundary, how the boundary is represented by means of group of pixels, we are representing the boundary. As well as region representation that refers the internal structure of the region. And the next one, description. Description that refers to the differentiating one class of object into the another class of object. While we are extracting the object, there are a lot of objects are there. For example, while we are extracting some animals in the image, there may be a dog, there may be a cat like this. We have to differentiate which one is dog, which one is cat. So the differentiating of these objects is referred as the description. And the last one is recognition. Recognition means assigning label to the object. After the object is extracted from the image, we have to say whether it is a dog or cat. Likewise, assigning label to that particular object is referred as the recognition. Knowledge base is representing the problem domain. Suppose if you are giving the satellite image and we are asking the question that whether there may be a cyclone formed or not, that is our problem domain. After processing the image, we have to tell whether there is a cyclone formed or not. So that is referred as the knowledge base. Next, let's see some of the applications of digital image processing. The first one is gamma ray imaging. If the images are captured by using the gamma rays, then that is referred as gamma ray imaging. Generally, it is used in medical field, which means if there is in this diagram some gamma ray, by using gamma ray, PET image is captured. In this diagram, we can recognize whether there is a bone fracture or bone infections, whether there is a tumor is there or not. Likewise, we are extracting some details. And the next one is X-ray imaging. Generally, we are known X-ray is generally used in medical field to check whether there is a bone fracture or not, as well as in angiography. While we are doing the angiography, all the details are monitored by using the X-rays. And in circuit boards, whether there is a flaws or not, whether there is any mistakes or there, whether there is any breakdown is there or not. Likewise, we are finding the flaws, X-rays are used. And the next one is ultraviolet band. Suppose if you are using UV rays, and that is referred as ultraviolet band imaging. Here, this is mainly used in agriculture field. Here the image is represent the corn, whether the corn has a disease or not. The first image is the normal corn, and the second one is the corn having the disease. While we are capturing the image and processing that, we can check whether there is a disease attacked or not for that corn. And the next one is infrared bands. By using infrared rays, we are capturing the image. This is generally used in industry. Suppose if you are using manufacturing some vessels in the sense whether the vessel is properly manufactured or not. Likewise, we are go through that. For that, infrared rays are used. And the next one is radio band. Radio waves are used to achieve that. In this techniques is generally used in MRI scan. In this bone, after scanning this bone, we can check whether there is a fracture or not, if there any water consistency is there, if there any fault in this bone or not. And microwave band. Microwaves are used to capture this image. This is generally used in radar applications. This is the image of the mountain. After while going and processing this image, we can say whether there is a human or animal movement is there or not. Likewise, in the security purpose, military use this technology. And the next one is, let's see about components of image processing system. While we are to do all the processing of this image processing, we need some of the components. The basic components are image sensor that is used to capture the image. After capturing, we can perform the manipulations by using some softwares. hardware that represent the physical device we are using, which means while we are capturing the image means we need some physical device which may be of camera or something else. Hard copy that represent the laser printer or some other pen drive, likewise the physical device which is used to maintain a copy. And next one is computer. Computer, it may be a personal computer to up to the supercomputer or mainframe computer. There are some computers needed to process the image. And mass storage, to store the image we need certain storage techniques are there. So what are all the storage techniques are there is come under the category of mass storage. And next one is image display. To display the image to the user, we need some output devices. It may be a monitor or a TV, likewise we can use any one of the output device. And network is used to transfer the image from one location to another location, which means one system to another system we need some network. These are all the things I have already explained. Physical device, for image sensing we need the physical device. After capturing the image, then that has to be converted into the digital form. For that we need some digitizer also, and hardware that is for the digitizer, as well as to make some pre-processing we need some ALU, which means arithmetic and logical units. And the third one is general purpose computer. To do the manipulations we need some computer, right? It may be a personal computer to supercomputer. Software is nothing but the application we are used to perform the manipulations. Generally we are using the Photoshop, that is also a software, right? And the mass storage, while we are making the processing, we have to keep the picture in the computer memory or buffer, and after that online storage as well as archival storage is there. For frequently used images are generally stored into that of magnetic disk or optical disk. If suppose we are infrequently used the images, in the sense that should be kept in the magnetic tape. And the image display, as I previously told, the display can be of anything like TV monitor or TV or stereo displays also we can use. And hard copy devices means to make a copy we need some printer, or for digital copy we can use some pen drive or CD-ROM, likewise we can use. And for networking we need the optical fiber or broadband technologies such as internet. And next let's see the first step. Already we have gone through the first step, right? Image sensing and acquisition. Let's see how the image is captured and converted into that of digital form. Okay. By using the sensor, acquisition refers that the light source is transferred into the object, then that will be reflected back and captured by using the sensors. So by depending upon the sensors, there are three technologies are there. The first we may use single sensor or sensor strip or sensor array. This is our sensor. By using the sensor, that is our input energy that is reflected back from the object. So by using the filter, we are capturing the energy and converting it into the voltage level. So that is the function of the sensor. So that sensor is loaded into that of rod. So there is a linear movement is done in that rod. Okay. While we are making the acquisition, so the sensor is moved from left to right to capture single line of data. That is by pixel by pixel we are capturing the data. So after the one line of data is captured, then the drum is rotated once. So after the single rotation, so the next line of data will be scanned. And there are two method of scanning system is there: mechanical scanning system and optical scanning system. As I previously told, mechanical scanning system is referred by means of the previously what I have told, and optical scanning system means instead of physical movement, the image is captured by using the lens and prisms. The advantage and disadvantage is in mechanical scanning system, the